Hello and welcome to today's lesson. In this particular topic of mathematics, we shall be discussing quadratic equations and graphs of parabolas. To begin with, we shall first of all look at how we can be able to express a quadratic equation in its standard form. So it's important for us to know that the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. So in this particular standard form of a quadratic expression, it's important for us to understand what A represents, what B represents, and what C represents. Now, class, what does A, B, and C represent? A, B, and C are constants. Now, it's also important for us to know that the value of A must exist for us to have a quadratic equation. That implies that A should not be equal to 0. So this symbol stands for not equal to. So A must not be equal to 0. So in this case, if A is not equal to 0, it implies that the term x squared will exist. So this first term, the first term ax squared is referred to as quadratic term. Then the second term is called the linear term. While the third term, C, in our case, stands for the constant term. Now, class, I'm going to give out some equations, and you should be able to identify a quadratic equation from a list of equations I'm going to write here on the board. Now, class, decide if the following equations are quadratic. The first part, A, is x plus 1 is equal to 0. The second part, B, is 1 minus 2x is equal to 0. The third one, part C, is x squared plus 3x plus 1 is equal to 0. The part D is 5x squared minus x plus 2 is equal to 0. And part E is x cubed plus x squared minus 2 is equal to 0. Now, we are going to identify the first part A by studying the equation given. When we look at part A, the highest power of x is 1. That the highest power of x is 1, and therefore the polynomial is called linear. So this is a linear polynomial. The explanation is the highest power of x is 1. In the second case, part B, 1 minus 2x is equal to 0, what will be the polynomial name? So in this case, the highest power of x is again 1, and therefore it's linear. In the third case, part C, we have x squared plus 3x plus 1 is equal to 0. And the highest power in this case is 2. The highest power of x is 2, and therefore the equation is quadratic. In part D, what is the name given to this polynomial? The name given to this polynomial will again be quadratic because the highest power of x is 2. Now, what will be the name of this polynomial in part E, which is x cubed plus x squared minus 2 is equal to 0. In our case here, the highest power of x is 3, and therefore such a polynomial is called a cubic polynomial. In our discussion, we shall only concentrate with the quadratic equations, that is, where the power of x is 2. The first one, where the polynomial is linear, has been dealt with in previous topic. And therefore, we shall only concentrate with the cases where the highest power of x is 2, and that particular polynomial is called quadratic equations. Now, class, we have this second illustration where we are supposed to write these quadratic equations which are given in standard form, that is in the form ax squared plus bx plus c is equal to 0, where a, b, and c are constants and a is not equal to 0. So in part A, the equation is x squared plus 2x is equal to 5, right in a standard form of the quadratic equation. Then in part B is x squared minus 5x is equal to negative 2. In part C is x squared is equal to 7x plus 2. In part E is 2 into brackets x squared plus x, close the brackets, plus 1 is equal to 0. Then part F is 5x is equal to 2, open brackets, minus x squared plus 5, close the bracket. So try part A. Now, I believe after trying part A, you have established that the first thing you do is to collect all the terms to the left-hand side so that we remain with a 0 on the right-hand side. To do that for part M, we need to study that particular equation, and having studied it, we realize that the constant term, which is 5, is on the right-hand side. We need to subtract 5 on both sides, that is left-hand side and right-hand side, so that we remain with a 0 on the right-hand side. So if we subtract 5 from both sides, we shall have x squared plus 2x minus 5 is equal to 5 minus 5. On the left-hand side, we are having x squared plus 2x minus 5, but on the right-hand side, we shall have 5 minus 5, which gives us a 0. So this now is our final equation, quadratic equation in the form ax squared plus bx plus c is equal to 0, and that is the standard form of any quadratic equation. In our case, the value of a is 1, the value of b is 2, and the value of c, which is the constant term, is negative 5. Try part B. Now class, if we study part B very carefully, you'll again realize that the constant term is on the right-hand side. And as I mentioned earlier, when you want to express in standard form of a quadratic equation, then all the terms must be on the left-hand side. So in this case, the quadratic term is already on the left-hand side, so we retain it. The linear term, which is minus 5x, is on the left-hand side, so we retain it. Then the constant term is on the right-hand side and is negative 2. So what do we do? Because it is negative 2, we add 2 on both sides so that we eliminate it on the right-hand side. So in this case, we shall have x squared minus 5x plus 2 is equal to minus 2 plus 2. And this simplifies to so if we add 2 on both sides, we shall have on the left-hand side x squared minus 5x plus 2 is equal to minus 2 plus 2 gives us a 0. So this is the general quadratic equation in standard form. Ax squared plus bx plus c is equal to 0. So that means a will be 1 because it's implied. B will be negative 5. What will be c? The c value is 2. But now we are only supposed to solve up to the step of expression. We don't need to identify value of A, B, and C. Try part C, where the equation is x squared is equal to 7x plus 2. In part C, the quadratic term is on the right-hand side. The linear term, which is 7x, is on the left-hand the quadratic term is on the left-hand side, which is okay. The linear term, which is 7x, is on the right-hand side, so we need to bring it to the left-hand side. We need to collect it to the left-hand side. Then the constant term is positive 2, which is again on the right-hand side. We need to collect it to the left-hand side. So in that case, we start with the linear term, 7x. Because it is positive, we subtract 7x from both sides. So we shall have x squared minus 7x is equal to 7x minus 7x plus 2. So on the left-hand side, we shall have x squared minus 7x is equal to, when we take 7x minus 7x is a 0, then plus 2. And 0 plus 2 is 2. So we just write 2. Now, we have a task of now collecting the constant term to the left-hand side. Because the constant term is positive 2, what do we do? So in this case, we subtract 2 from both sides. So on the left-hand side, we shall have x squared minus 7x minus 2 is equal to, on the right-hand side, we shall have 2 minus 2, which gives us a 0. So that means our final equation in standard form will be x squared minus 7x minus 2 is equal to 0. Where a will be 1, b will be negative 7, which is the coefficient of the linear term, and c is negative 2, which is the constant term. Now, class, suppose we have a situation like the one in part A. How do you handle? Because in this case, we have a 2, open bracket, x squared plus x, close the bracket, plus 1 is equal to 0. Now, in this situation, because 2 is multiplying the bracket, we use BODMAS to open the bracket. So we open the bracket, that is 2 multiplied by x squared, which will give us 2x squared. Two multiplied by x is positive 2x. Then finally, plus 1, 0. So here we are only supposed to open the bracket. So this particular equation, quadratic equation, is in the form ax squared plus bx plus c is equal to 0. Where a is 2, b is positive 2, and the constant term is positive 1. Now class, what will be the expression for such a situation like in part F, where we have 5x is equal to 2, open bracket, minus x squared plus 5, close the brackets. Again, just like in our previous example, the left-hand side is simplified, so we shall have 5x. Then the right-hand side, we have a 2 outside the bracket, and therefore we open the bracket by multiplying 2 by the first term in the bracket, 2 multiplied by the second term in the bracket. So in this case, it's 2 multiplied by minus x squared, which is minus 2x squared. Then what is the value when you multiply 2 times 5? When we multiply 2 times 5, the value we get is 10. So we write plus 10 because 10 is positive. Then, by looking at it, again, we find that the quadratic term is on the right-hand side. We need to collect it to the left-hand side. The linear term, which is 10, is on the right-hand side. We need to collect it to the left-hand side. So let us start by the quadratic term. How do we collect the quadratic term to the left-hand side? To collect the quadratic term to the left-hand side, because it's minus 2x squared, we add 2x squared on both sides. So if we add 2x squared on both sides, on the right hand side, we shall have negative 2x squared plus 2x squared is a 0. Then plus 10. So 0 plus 10 is simply written as 10. So on the right hand side, we remain with the 10. Then on the left-hand side, we shall have (5x plus 2x squared). So this can be written as 2x squared plus 5x. So 2x squared plus 5x is the same as 5x plus 2x squared, because we understand that in addition, the order does not matter, because we can start with the 5x followed by 2x squared or we can start with the 2x squared followed by 5x. So in addition, the order does not matter. So addition is commutative, and therefore the order does not matter. So at this point, we are left with the 10, which is a constant term on the right-hand side. So what do we do? To express this particular equation in standard form, we are supposed to subtract 10 on both sides because 10 is positive. If we subtract 10 on both sides, we shall have 2x squared plus 5x minus 10 is equal to 10 minus 10. Why did we subtract? We subtracted 10 on both sides because it is positive. So to collect it on the left-hand side, we subtract so that we eliminate it on the right-hand side. So that gives us the final expression, the final equation as 2x squared plus 5x. So there's a problem here. So this gives us the final expression as 2x squared plus 5x minus 10 is equal to 0. So we say we have now written the quadratic equation in the form ax squared plus bx plus c is equal to 0. So in our case, what is a, class? I believe you have discovered that a is 2 by comparing the coefficient of x squared. Then b, what is the value for b? Again, I believe by inspection you have discovered that b is 5. What is the value of c? The value of c is negative 10. So that is generally how we express quadratic equations in standard form. Ax squared plus bx plus c is equal to 0. Now, class, we want to now extend our knowledge to solving quadratic equations using a method called Null Factor Law. So first of all, we need to understand what does Null Factor Law state. The Null Factor Law states that if the product of two numbers is 0, then either or both of the two numbers is 0. A case example is this. If we have the first number as a and we are multiplying by b, product means multiplication. So we are multiplying, in this case, two numbers. A multiplied by b. So the first number is a, the second number is b. So the product is 0. So a times b is equal to 0. Then a is 0 or b is 0. Because when a is 0, 0 times b, the result will be 0. We know that any number multiplied by 0, its result is 0. Let us look at this case too. If we have the first factor, which is x plus 1, is our first linear factor. We are multiplying by a second linear factor, which is x minus 3, and the product is a 0. Then it means if we take the first linear factor, x plus 1 will be equal to 0. Or if we take the second linear factor, which is x minus 3, will again be equal to 0. Taking the first linear factor x plus 1 is equal to 0, we can be able to solve it and find the value of x. So in this case, x plus 1 is equal to 0. Class, what is the value of x? So if x plus 1 is equal to 0, we can find the value of x by subtracting 1 from both sides. In our case, x plus 1 minus 1 is equal to 0 minus 1. So, on the left-hand side, we shall remain with x, and on the right-hand side, we have negative 1. So, the result is x is equal to minus 1. That will be the solution. Then, using the second linear factor, x minus 3 is 0, when you look at the term, which is the constant term, is negative 3. So to remain with x, or to make x the subject, we add 3 on both sides. So we shall have x minus 3 plus 3 is equal to 0 plus 3. So that leaves us with on the left-hand side, minus 3 plus 3 is 0, so we remain with x is equal to, on the right-hand side, we have 0 plus 3, which is 3. And therefore, the solution will be x is equal to negative 1, or x is equal to 3. That's how we can use the null factor law to solve quadratic equations. What happens when we expand these two linear factors? So x plus 1 and x minus 3 are called linear factors. So we can be able to expand this by opening the bracket to obtain the original quadratic equation. So class, try to expand x plus 1, x minus 3, and obtain the corresponding quadratic equation. So class, to expand x plus 1, x minus 3 is equal to 0, we first of all take the first term in the first bracket, which is x, multiplied by the second bracket. Then we take the second term of the first bracket, which is positive 1, and we move with the sign, multiplied by the term in the second bracket, or the two terms in the second bracket, so which is x minus 3, which is 0. So when you open, x times x is x squared, x times minus 3 is minus 3x, 1 times x is x, 1 times minus 3 is minus 3, and that gives us a 0. Collecting the like terms, we have x squared minus 3x plus 1, x. 1 is implied, so minus 3 plus 1, you remain with minus 2x, minus 3 is equal to 0. So we can say that x plus 1 and x minus 3 are linear factors of the quadratic equation x squared minus 2x minus 3 is equal to 0. So that means x plus 1 and x minus 3 are linear factors of the quadratic equation x squared minus 2x minus 1 is equal to 3. Let us look at more examples on how we can solve a quadratic equation using the null factor law. Now class, let us look at more examples on how we can solve a quadratic equation using the null factor law. For example, solve these equations. The first one, part A, is x minus 1 bracket x minus 1, close the bracket, into x plus 5, close the bracket, is equal to 0. The second one, part B, is open bracket, 2x minus 1, close the bracket, open the bracket, 5x plus 3, close the bracket, equal to 0. Class, try part A. So I believe that you have made an attempt on part A. We have two linear factors. What are the linear factors here, class? The linear factors are x minus 1 and x plus 5. The product of the linear factors is 0. It means, using the null factor law, that the first linear factor will be equal to 0, or the second linear factor, which is x plus 5, will also be equal to 0. Taking the first linear factor, x minus 1 is equal to 0, we can be able to solve and find the value of x. Because we have x minus 1, to find the value of x, we add 1 on both sides. In this case, we shall have x minus 1 plus 1 equals to 0 plus 1, which gives us x is equal to 1. Now, class, how do you find the value of x for the second linear factor, x plus 5 is equal to 0? Again, to find the linear factor, the value of x for the second linear factor, x plus 5 is equal to 0, because we have positive 5, we subtract 5 from both sides. If we subtract 5 from both sides, we shall have x plus 5 minus 5, which leaves us with x. Then on the right-hand side, we have 0 minus 5, which gives us negative 5. Therefore, we can say the solution using the null factor law for x minus 1, x plus 5 is equal to 0 will be x plus 1, x is equal to 1, or x is equal to negative 5. So the two are the solutions for these particular linear factors, x minus 1, x plus 5 equal to 0 using null factor law. Now class, try this second part B, again using the same method, null factor law, where we have open bracket 2x minus 1, close the bracket, then open the bracket, the second linear factor is 5x plus 3 equal to 0. I believe you have discovered that the first linear factor is 2x minus 1, we equate it to 0. Or the second linear factor, 5x plus 3, again is equal to 0. Taking the first linear factor, we can be able to find the value of x by first of all adding 1 on both sides. Because it's minus 1, we add 1 on both sides. If we add 1 on both sides, we shall have 2x minus 1 plus 1, which is equal to 0 plus 1. On the left-hand side, we shall have 2x equals to 0 plus 1. The result is 1. Now, what is the value of x? To find the value of x, we divide both sides by 2. If we divide both sides by 2, we shall have 2 divided by 2, which leaves us with x. Then 1 divided by 2 is a half. Therefore, the solution to the first linear factor 2x minus 1 is equal to 0 will be x is equal to a half. To obtain the solution to the second linear factor, 5x plus 3 is equal to 0, we subtract 3 on both sides. So in this case, we shall have 5x plus 3 minus 3, which leaves us with 5x. Then on the right-hand side, we have 0 minus 3, which leaves us with minus 3. Now, class, how do we find the value of x, given that 5x is equal to minus 3? To find the value of x, we divide both sides by 5, which is the coefficient of x. Five and 5 cancels. We are remaining with x on the left-hand side. Then on the right-hand side, minus 3 over 5 leaves us with negative 3 over 5. And therefore, the solution to this linear factors, 2x minus 1 into bracket 5x plus 3 is equal to 0, are x is equal to a half or x is equal to minus 3 over 5. That is how we use the null factor law to find solutions of given linear factors of a quadratic equation. Now, class, let us now extend the same knowledge of solving the quadratic equation using the null factor law in more complex illustrations. So, in this example 3, solve this polynomial equation using the null factor law. First of all, what is a polynomial? Polynomials are sums of integer powers of x. Sums means there is addition of integer powers of x. Like here we have x plus 1. What is the power of x here? The power of x in the first linear factor is 1. So we call that a linear polynomial. X minus 3. X is a variable and its power is 1 and therefore is a linear polynomial. X plus 2. The power of x is 1, and therefore x plus 2 is again a linear polynomial. But now, we want to solve this case where we have more than 2 linear factors. So here we have a total of 3 linear factors. We use the same concept that the product of any linear factor, if the product of the linear factor is 0, then it means either one of the linear factor is 0, the first linear factor is 0, or the second linear factor is 0, or the third linear factor is 0. In this case, for example, if we take if we have A times B times C is equal to 0, it means either A is equal to 0 or B is equal to 0 or C is equal to 0. In our case, instead of A, we are having the first linear factor as x plus 1. So in this case, we don't use A, but instead we write the first linear factor x plus 1 equal to 0, or the second linear factor x minus 3 equal to 0, or the third linear factor x plus 2 is equal to 0. Then at this point, we find the value of x for every linear factor. Let us start with the first linear factor, x plus 1 is equal to 0. Class, what will be the value of x? In this case, because we have x plus 1 equal to 0, the constant term is positive. We subtract 1 from both sides. That is x plus 1 minus 1 equals to 0 minus 1. So 1 minus 1 is 0. So on the left-hand side, we shall remain with x. What about the right-hand side? Which value will be on the right-hand side? On the right-hand side, we shall have 0 minus 1, which is minus 1. So that is, the solution to the first linear factor x plus 1 is x is equal to minus 1. Or, if we pick the second linear factor, x minus 3 is 0, the constant term is having negative 3. And therefore, what do? We add 3 on both sides. So on the left-hand side, we shall have minus 3 plus 3 is 0. 0 plus 3 is 3. So the solution to the second linear factor x minus 3 is 0 will be x is equal to 3. Or if we pick the third linear factor, x plus 2 is equal to 0. Because the constant term is positive 2, we subtract 2 from both sides. So in this case, we shall have x plus 2 minus 2, which is equal to 0 minus 2. If we take x plus 2 minus 2, on the left-hand side, we shall remain with x. 0 minus 2, on the right-hand side, we shall have minus 2. So that means the solution to this 3 linear factor will be x is equal to minus 1, or x is equal to 3, or x is equal to minus 2. That will be the solution to this particular linear factors using null factor law. Now, in this case, we want to extend the knowledge of solving quadratic equation using the null factor law, but in situation where we have x squared minus 4x plus 3 is equal to 0, where we don't have now the linear factors directly, so we need to look for them. In part B is x squared plus 3x is equal to 0, and in part C, there is x squared minus 16 is equal to 0, which is a difference of two squares. So let us look at part A. How do we solve? To solve part A using null factor method, first of all, we need to use trial and error method to find the factors. So to find the factors, look for two numbers such that by inspection, method, we look for two numbers such that their product will be 1 times 3. That is, we take the coefficient of quadratic term, in this case is 1, and the constant term, which is 3. So in short, we are taking A times C, which gives us positive 3. And the sum, if you add the two numbers you have obtained by trial and error method or inspection method, we are supposed to get the sum as the coefficient of the linear term, in our case, is negative 4. So, you must be guided by the product. We look for those two numbers using trial and error method. Class, which numbers do you multiply? The two numbers you can multiply and obtain positive 3. And when you add, that is, you sum up, we get negative 4. The two numbers are 1 and 3, and 1 must be negative, 3 must also be negative, so that when you add, we get negative 4. Since negative 3 plus negative 1 is negative 4, and therefore we shall pick our two numbers and factorize. So we split the middle term, which is the linear term. So in this case, we factorize the first two terms, which is x is common. So the first term, x is common. The second term, x is common. So we factorize, we put it outside, x into x minus 1, because x squared divided by x is x. 1x divided by x is 1. Then in the second bracket, the third term and the fourth term, the common factor is negative 3. So we factor out negative 3. So negative 3x divided by negative 3 is x. Positive 3 divided by negative 3 is negative 1, which gives us a 0. So the linear factors will be, we write the repeated one, x minus 1 first, followed by x minus 3. as the second linear factor. Then from here, we use we now use the Null Factor Law to get the value of x. So the value of x for the first linear factor, x minus 1 is 0, will be x, you add 1 on both sides, negative 1 plus 1, 0 plus 1. So we shall have x is equal to 1 as the first the first solution. Or, using the second linear factor, x minus 3 will be 0. You add 3 on both sides because we have x minus 3. The constant term is minus, so to collect it on the right-hand side, we now add 3 on both sides. So on the left-hand side, we shall have x. On the right-hand side, we have what? We shall have 0 plus 3, which is 3. So the solution will be x is equal to 1 or x is equal to 3 for that linear factor. Class, try part B. X squared plus 3x is equal to 0. To find the value for this, because x is common for the first and second term, we factor out x. So we shall remain with x squared divided by x, we remain with x. 3x divided by x, we remain with 3. So the factor will be x into x plus 3, close the bracket, equal to 0. So if we use the Null Factor Law, the first factor, x will be 0, or x plus 3 will be equal to 0. X will be 0, or we subtract 3 on both sides for the second linear factor, x plus 3 is equal to 0. So we shall have x plus 3 minus 3 equal to 0 minus 3. So finally we shall have x on the left-hand side, 0 minus 3 on the right-hand side, we shall remain with minus 3. And therefore the solutions are x is equal to 0 or x is equal to minus 3. Then finally, as we conclude, we look at the last part C. So in part C, we have x squared minus 16 is equal to 0. Class, when you study this particular quadratic equation, we have only two terms, the quadratic term and the constant term. The quadratic term is being squared, is x squared. Then this constant term can be written as a square also, that is minus 16. What is the square root of 16? It is 4. So we can simply write 16 as 4 squared. So that means we are having the difference of two squares. There is a square of x, which is x squared. There is a square of 4, which is 4 squared, and that gives us 16. So to get the linear factors for this particular quadratic, where we have a difference means the subtraction. There's a difference of two squares. What we do, we pick the first value. Like here we have x squared, so we shall only pick x. Then, in the second factor, we pick 4. because it's being 4 squared. So we only pick 4. So there is a plus. Then the second factor should be x minus 4 is equal to 0. Let us try to open and see whether we confirm by opening and see whether we shall get x squared minus 16. Try out. So x times x, we have x squared. X times negative 4 is minus 4x. 4 times x is 4x. 4 times 4, negative 4 is negative 16. So you find that if we open the bracket, we get that value. So that means if we have a difference of 2 squares, for a difference of 2 squares, for example, a squared minus b squared is equal to 0, then its factors are a plus b, a minus b is equal to 0. So in our case is x squared minus 16 is 0. So the factors will be x plus 4, x minus 4 is 0. So using null factor method, we shall have x plus 4 is 0 or x minus 4 is 0. So that means if we solve the first linear factor, we subtract 4 on both sides because it's positive. So we shall have x minus 4 plus 4 minus 4, 0 minus 4. So on the left we have x, on the right we have negative 4. That will be the solution. Then on the right, because it's x minus 4, we shall have, we add 4 on both sides, that is x minus 4 plus 4, which is equal to, on the right hand side, we take 0 plus 4. So the last linear, the solution will be x is equal to 4. So basically, we have looked at how to solve quadratic equation using the null factor law, and we have looked at all the cases where already you have been given the linear factors. That one you go direct by equating the first linear factor to 0 and equating the second linear factor to 0. We have also looked at a situation where we have the 3 linear factors, and we have said you equate the first linear factor to 0, second linear factor to 0, and third linear factor to 0. We have extended the same knowledge to cases where we need to factorize an expression first, and we have said to do factorization, you use inspection method, whereby you look for 2 factors and split the middle term to get the linear factors. Then having the linear factors, you apply now the null factor law to find the solution to that particular quadratic equation. Then in conclusion, we have also looked at the last one where we have the difference of 2 squares, like in a case where we have a squared minus b squared is equal to 0, and we have said to get the linear factors, you just take the first term, which is a squared, you take a plus b, then the second linear factor will be a minus b is equal to 0. That marks the end of our lesson, and let us stop at that point until we meet next. Thank you.